It's very rare that I teach a lecture that isn't based around some problem. There is a problem and we have to solve it, and how are we going to do that? I think framing it as a problem, it lets you do that thing where you don't overload the students all at once.
So we're dealing with digital communication systems, right? That is the whole point of this class. And right now, for these 6 or 7 more lectures, we're really focused on the process of encoding. Right? How do we get data into bits and what matters?
So most of the time, I'll basically start at the highest level. What's the kind of 1-sentence goal of this algorithm? What is it meant to do? And then just start breaking it into chunks so that each piece is sort of a thing that can be said relatively succinctly, and so that we have a way to build up the material. What they commonly see from me is, here's this piece of code. Okay, what's the problem with this? Like, what is wrong with it? Typically, we need to write a piece of code that does something. And so we build up to that solution by writing something that seems simple and then figuring out what the problems with that are.
W is a 0, X is 0, 0, Y is 0, 0, etc. Now, shout out at me what is wrong with this.
When does this work? And a lot of times the simple solution does work in some cases. And then we can say, okay, well, when does this fail? All right, here's edge case number 1. It didn't work here. So let's try to fix that.
Now, tell me, what do you notice? Do you notice anything different in structure between this tree over here and the first tree that I drew?
When you just say, here's the problem we're going to solve and here's the solution, that's great. They might understand the solution, but they don't really understand why it's there, like maybe why you need to address all of these components, or what is this line of this algorithm for? They just kind of say, oh, this is a solution. This is just what I use. So if you can answer the why, like if you can get that out of the way immediately, then the student is sort of ready for details. They are a little bit more, I think, accepting of details. Like you might present them a couple, lines of the algorithm, and then they'll go back and explain it. I think if they understand what you're going for, they aren't freaked out by those 3 lines of code, even when they don't quite understand what they do yet. The way that they might be if they have no idea what the special thing about this algorithm is.
Is this the best that we can do? Or can't you tell?
It lets you sort of, piece by piece, introduce the edge cases that you have to take care of. It lets you piece by piece introduce the actual solution. So you're not starting with the whole solution there, you're building it up. And I think it lets them feel, once they see the solution, like, I understand this. I understand all of this code because I know how we got there. Occasionally there's, problems or algorithms or whatever that I have to explain where, we might build up to something and then the final solution is actually, kind of different from everything that we built up, because it seems like, we started from this basic point and kept fixing and kept fixing and kept fixing, and it just never worked. We kind of needed a clean slate design. But I think that in itself, that's also illuminating, right? Like, it lets the students understand the problems that are faced along the way. It lets them understand, why this particular thing was designed in that way, because these alternative designs don't work. I think if you understand why they didn't work, then you come to understand why the correct solution does work.
Okay, so we could definitely do better. You're right, we can definitely do better. Is there anything that you see in this tree that could make this code better? Yeah?
But so I'll ask them a lot of questions. Sometimes I'll kind of survey the class, like thumbs up if you think this, thumbs down if you think that.
You will also know, I tell every class, usually during the first lecture this, I will ask you questions a lot in lecture because it's not fun for any of us if it's just me talking the whole time. You're also gonna learn better if it's interactive, all right? A lot of the questions that I will ask you are not super hard. I just accepted yes as an answer for how big is the internet, okay? They're not, but I always get like this feedback from students, from a small subset of students that says like, we really hate that Katrina asks these easy questions because we don't want to answer. Because we feel like if we get them wrong, she'll think we're dumb or our friends will think we're dumb. I will never think you're dumb, ever. I will be so excited that you're answering a question. If I ask you the value of a bit, you tell me it's 0 when it's 1, I will tell you you are 95% of the way there, okay? I will be psyched that you were answering.
Another common thing that I've done is not bring students up to the class or to the front of the class, but say, okay, this side of the room is doing this thing, this side of the room is doing that thing, so they kind of feel like they're involved. Other things that I've done in lectures, if I have a lecture where I feel like what we're doing is sort of really complex, which today's was almost getting to that point where we're just, we have to kind of look at the internals of some system. We have to look at a lot of code, which it could just be a lot, no matter how you present it. I'll actually build in a break in the middle of the lecture. I realize that you might need a break, so let's take a quick break. But yeah, I think there are lots of ways to kind of just sort of zoom out from where you are and remind the students how you got there and what they're doing. And I think that even if you're still teaching, you're not explicitly saying we're going to sit here for 10 seconds and wait, that still serves as a break because it gets them out of thinking about, internal details, going back to the high level stuff. Another way which I try to engage them in the class is introducing the next step to them by telling them, at this point, here's what we should be asking ourselves. And I think it's good in many ways. I think it's a good way to progress through material. I think it can also be reassuring for many students that, oh, I did have that question, and maybe before I thought that I was just supposed to know the answer, and oh no, I don't know the answer. Katrina hasn't taught it to me yet, so this is good. Kind of reassuring them that they should have questions as we go through the lecture, and those questions are sort of the right ones. Part of delivering a good lecture is figuring out a way to keep the students interested in what you're doing. So you've got to sell it to them in some ways. And I think part of that is just in the context of the technical content, you should be able to express to them why this is important, why this is interesting.